Alright, simplifying radicals part 2. Looking at radicals with variables. So quick review. Yesterday we looked at stuff like this. The square root of 200 is the same thing as the square root of 2 times 100. And we learned the square root can break up over factors. So that's the same thing as the square root of 2 times the square root of 100. And often we can do that, or we do that because we can simplify one of those factors. So the square root of 100 is just 10, and the square root of 2 just stays there. Well, now we're going to look at, what if we had a variable thrown into this mix? So what if we had another factor here? Instead of just 200, what if we had something like the square root of 200 x to the 4th?
Isolate the variable.
Okay, so we could separate the variable off. The way that we would do that with square roots is like this, right? So we're just simplifying here. Does anyone want to think about, like, what would be the square root of x to the 4th? The 4? You can't because it's an exponent.
Wouldn't you just find out wouldn't you find out what the perfect square of 200 is?
Okay, so we would do this the same way. We've got 102, and so we would say square root of 100, square root of 2, so 10, square root of 2. What are we going to do with this? What do you think the square root of x to the 4th is? Why? Okay, because x squared times x squared is x to the 4th, right? So the square root of x to the 4th would be x squared. And then we would put that right next to the 10. We're going to put it in front of the square root. So our final answer to this problem would be 10x squared times the square root of 2. Yep. We're moving our factors all around, right? We can't solve it because we don't have an equals sign, right? So we're just simplifying. We will eventually be solving problems with radicals in this. But it's actually a little bit of a different problem. Can I erase this now?
Yeah.
Alright. Let's try another one. So what if I had something like this? The square root of 25 x to the 10th power.
Wouldn't we do the same thing?
So what do we do?
Isolate the x to the 10th.
Okay. So we could think of it as the square root of 25 times the square root of x to the 10th. What is the square root of 25? We already know that, yeah, it's just 5. What's the square root of x to the 10th? Yeah, why?
Because x
We're done. Let's just do some practice. What do you think the square root of x to the 12th is?
x to the 6th.
What do you think the square root of x to the 18th is?
X to the 6th.
What do you think the square root of x to the 200th?
X to the 100.
What are we doing? How do we find the square root? It's just half of that exponent, right? Wait a second. What did I say yesterday about a square root?
It's your
Certainly
perfect.
has something that goes into it, but when
when you do, with exponents, the exponent rule was like, you multiply, you just multiply the numbers, and then.
Well, I also said the square root of x is the same thing as x to the, look in your notes. What did I say? From yesterday? No? Remember we had that whole list, like the square root of x is x to the cubed root.
Oh
of,
yeah, x to the 1/2.
Yeah, exactly.
X to the 1.
The square root of x is x to the 1/2. So we're just saying
Oh.
1/2 of 12, 1/2 of 18.
Wait. but
That's
then-
how we do the exponents.
But what if we put like a 3 in that little triangle thing?
Yeah, we're not going to talk about that
Wait, but
part today.
wait, so
That would be
why
totally
is-
different.
Why is it like 25 is 5?
Because that's the exponent, right? So we're separating the exponent and the actual factors. So like the square root of 25 is 5. It's not the square root of x to the 25.
Wait, so
Because
wait,
that would be x to the 12.5.
wait, is 25 to the 1/2 power the same as 5? So you're
Uh-huh. So we could also write this as 25 to the 1/2. And that would also equal 5.
Wait, so your answer though would be just 5x to the 12.5 or what?
Well, okay, so actually that's what I wanted to talk about next. What if you had an odd exponent?
You would get.
So what if I had something like this? What if I had the square root of 32 x to the 5th?
Wouldn't you get x to the 2.5?
Okay, I could. So on the x to the 5th, I could think of this as x to the 2.5. We don't usually see in Algebra 1 decimals
Could you
as
do a fraction?
exponents. So is there another thing we could do to make it so that we have an even exponent?
Multiply it.
We can multiply it.
No. We can't really change it, but just like how would you take care of this 32? What would you do to the 32?
break it down?
We'd break it down into this, right? Do you guys agree? What could I break x to the 5th down into? X to the 5th is x to the 4th times x.
Do that.
Right? So then the square root of 16 is 4. Square root of x to the 4th is x squared. And there's nothing we can do with these, so we're actually going to combine them. And leave them behind in the square root. What if I had something like this? Square root of 8 x to the 11th.
Oh, couldn't you break that up so you could do 4 and 2?
Okay, so this is 4 and 2.
And then you do x to the 10th plus, and then x.
X to the 10th and x. Okay, so we've got the square root of all of these things, right? We've got the square root of 4, the square root of x to the 10th, the square root of 2, and the square root of x.
And then couldn't
Why do you think I wrote them in that order, not this order?
Because you're going to add those two variables. You're going to add 4 and x to the 10th and 2 and x.
Yeah, I'm gonna like combine, I'm not gonna add them, right, but I'm gonna combine them,
Wait, and then couldn't you break down 4?
and I can break these down. So what is the square root of 4?
2 and 2.
2. What is the square root of x to the 10th? X to the 5th. And what do I get here?
Square root of 2x.
So when I have an odd exponent, I just break it down into an even exponent and an x. there's only ever going to be one left over because we're only ever one away from an even number, right? Can anyone think of a number that's 2 away from an even number?
Yeah. 2. 2 away from 4.
But it's 0 away from 2, right? So it is an even number.
It's also 2 away from
Oh, I see what you're saying.
Wait,
It's
is
like a-
negative? Like, are
Any number, right? Any even number is 2 away from the next even number.
wait, negatives have even numbers, right? Does it not? It doesn't change, right?
Negatives, we're not actually going to go into negatives with this. Okay? With this particular thing.
Because then negative one should be like 2 away from 3.
Yeah. Okay. Actually, is 0 even, or I don't know if 0 is even or odd or not.
0 doesn't have a number identity.
Yeah, I don't know the answer to that. I probably should, but I don't. Okay. All right, let's do a couple of examples. I want you to do these examples in your notes. All right. Go ahead and try these on your own. I want to put the answers on my.
Oh, is that 144?
Uh-huh.
Oh.
All right. What do you guys think this one is?
X. X is X is 6.
Any other answers? Okay. What's an answer you got here?
5 in the third, to the square root of y.
Yeah, so the way I would say this is y to the third times the square root of y. Even though I don't actually write a times, that's just how I would say it. Okay. Any other answers for that one? Okay. How about this one?
2x to the third times the square root of 2.
Any other answers for that one?
I just got 2x to this. Yes, in here.
Let's look at those. Where do you think, where does this 2 come from? Yeah, the square root of 4 is 2, right? And then where does the x to the third come from?
X to the 6th.
Square root of x to the 6th, right? Is there anything left? Yeah, so we don't really need this. Just 2 times x. 2x to the third. Alright, how about this one?
6x to the 3rd.
Mm.
I got 2x to the 4th times square root of 3x.
I got 4x to the 2nd, and then square root 3x to the 5th.
Wow. Say that again.
I got 4x to the 2nd, square root 3x to the 5th.
Okay. One thing I want to point out about this answer, we're never going to leave more than one variable in the square root. So if you have x to the 5th in your square root, you're going to want to take the x to the 4th, pull it out, and leave the x. Does that make sense? Like x to the 5th is x to the 4th times x, right? So I would want to get that out and make this x to the 4th, and then just leave an x. Like I mean, this could be correct, but it wouldn't be finished. Do you see what I'm saying? There would be another step we could do. Actually, now that looks really similar to this one, doesn't it? Do we take half of 12? Is that what we do? Do we, to get 6?
No.
No, right? What do we do with the 12?
We
Oh,
split
wait a
into
minute.
variables we can turn into.
Yeah, we split it into 2 factors that we can turn into a perfect square and a not perfect square. What is the square root of 4? 2, right? So I see where all these numbers came from. The 6 was half of 12, right? The half only applies to exponents. Right? We're only taking half of the exponent. And the 4 is the number that we had here, but we just forgot to take the square root of it, right? So then we would end up with 2x to the 4th, because that's half of 8. There's 1 left over, and there's a 3 left over. So 2x to the 4th times the square root of 3x. All right, how about this one?
12x to the 2nd power times y to the 8th power times the square root of xy.
Any other answers? Same thing?
No.
Yeah. Square root of 144 is 12. X to the 5th, we think of x to the 4th. Half of 4 is 2. And we leave an x behind. Y to the 17th, we think of 16, and half of 16 is 8. And we leave a y behind. So eventually you should get to the point where you can do these pretty much in one step, I think. A lot of these. By kind of looking for these patterns, right? Like we're only ever going to leave one x or y behind. If we have an odd number, we're going to have one left behind. If we have an even number, there's no more square root. We got rid of it, right? I want to just talk, the last thing in this lecture is, what if we have more than one variable, like that last problem? So if we have something like the square root of 4x to the 8th, y to the 9th, what if we even have another variable, like z to the 10th? What do we do? Well, we just do each one separately, right?
Yeah, so it'd be 2.
So the square root of 4 is 2. Good.
It'd be
Square root of x to the 8 is x to the 4th. The square root of y to the 9th is,
is 8 and then 1.
yeah, so we think of it as 8 and then 1, right? 8 and then 1. Did I do that right? Why not?
Because you have to divide the 8.
We have to do half of the 8, right?
Why?
And z, because it's inside the square root, it's 8 and 1, right?
Yeah,
To
but
get it outside of the square root, I have to do half of that extra. So what I have here, if I were to show the intermediate step, is I have this. The square root of 4, the square root of x to the 8, the square root of y to the 8, the square root of y, and the square root of z to the 10th. Do you agree with that? Because when I have an odd number, I have to pull it apart. But the square root of y to the 8 is not y to the 8, it's y to the 4th. Right? Okay? And then what's the square root of z to the 10th? Z to the 10th. And that's it. Now, I do want to show you one last way of doing this that actually a student, something like 7 years ago, came up with. Which is, he thought about that half power thing that we just talked about. So, he would look at these like this. If I have the square root of x to the 8, y to the 9th, z to the 10th, I'm just going to take half of every one of those. X to the 4th, y to the 4.5, z to the 5th. And then he said, okay, I took half. Now I go back and look. If I have a decimal, I get rid of it, and I make a square root over here. So now I say x to the 4th, y to the 4th, z to the 5th, square root of y. Because the decimal goes into the square root. So it's just another way of thinking about it. You should always get the same answer. But some people like this method better. Because it's just literally just taking all half of everything and then finding the decimals and moving them back into the square roots. So kind of a cool method that a student invented.